Okay, so to get some movement happening, let's double click on our player script, and we're going to create a couple of variables at the top here. We're going to create a public float, and we're going to call this player speed. If you start with a small p or small letter, and then you whenever you write a uppercase letter, it will actually split that. And the reason we say public is so that we can access that in the inspector. So if we go over to the inspector and we go over to the player, you'll see that we have now a player speed variable here, and you'll see that it's split at player, speed, and it looks nicely formatted. So these are just coding best practices. And we want to create a, we don't need to access this in, actually we'll create a public, we do need to access, we'll make it so it's public. Public float directional speed. Okay, so now we have two variables, player speed and direction speed. So player speed will deal with like how fast the actual ball is, the player is moving forward, and the directional speed will be how fast it moves left and right. So we actually are already using we're already using this number somewhere, right? So we're actually using it down here. We're timesing vector3.forward by 1,000. We can change this 1,000 to player speed. And if we press save and we go back over to our game, you'll see that we should have two variables here pop up. And if we press play, you'll notice something very interesting. First of all, nothing happens. Why is that? Nothing's happening is because the public float player speed, we are now timesing vector3.forward by player speed, and player speed currently equals 0. So what happens in maths when we times something by 0? It equals 0. So if we can actually change this in here. So we can actually drag this forward and forward. And you'll notice that at 184, that's how fast our player is moving. We could make this 1,000, and that's how fast it was moving before. Or we could actually make it negative 500. And yeah, they're all numbers, they all do stuff. And negative 500 means it's actually moving backwards, but you can see now it's under the floor. You get some wacky results. We can actually create the default in here. So let's say, because we were using 1,000 before, that was a little bit fast. Let's say 500. So we can say equals 500. So now it should default as 500. If we want to go back over to the player script, we can click reset and it will come up as 500. Now, whatever adjustments we make here will then override whatever number is in here. So just make sure, sometimes it's a bit of a gotcha. You'll be wondering, why isn't my script working? Just make sure that this number here, or this number here, more is the number that you actually want it to be. Cool. So the next thing we want to do is we want to actually create a float. Now this float will only be used inside of updates, so we don't need to actually declare it up here because it's not a class variable. It's not a variable that's going to be used throughout the whole class. We're just going to be using it once and then basically throwing it out. So we're going to create float, and we're going to call it move horizontal. I hope I spelled that right. And we're going to equal that to input dot get access, open parentheses, and then we're going to open speech quotes, and we're going to type with a capital horizontal. And once again, close every line with a semicolon, and we're just going to debug that out. Debug.log move horizontal, so we can see what's going on. So if we press play, ignore the game object for a moment, and we're going to go over to our console. We'll see that we have 0. Now, if you press right on your keyboard, so click on the game, you press right on your keyboard, you'll see that it goes up to 1 and to -1. And you know it changes when you press left and right on the keyboard. This is because we're accessing the Unity inbuilt function called input, and we're getting information from the keyboard, and we're assigning it to a variable called float, a float variable called movement horizontal. So we can get rid of this debug.log, and then the next part might be a little bit confusing. we're going to write transform dot position. So what is the transform dot position? So if we go back over to our player, we'll get a bunch of errors pop up if you've done what I've just done there. Don't need to follow along, but just watch. If we go over to our player, we'll see we've got our transform up to here. So once again, we're accessing something on the game object. We're accessing the transform and we're accessing the position. So we got an X value, we got a Y value, which is up and down, and we got a Z value. And we're just going to zero all those out. And we go back over to script and we're saying transform.position. So we're saying, well, we want to access this thing, and we're going to equal that to something. And what are we going to equal it to? Well, we're going to equal it to, we could equal it to vector3.forward or something. We could equal it to a bunch of different things. But what we want to do is we want to equal it to a new position. So what we're going to say is vector3.lerp. So lerp is linear interpolation. So it basically is a smooth movement between two different spots. And right now you can see it's asking for a vector 3A position, a vector 3B position, and a time it's going to take to get there. So if this is confusing you, I don't blame you. This is the kind of stuff that you learn while you learn more and more as you get better at programming. This is just the syntax that Unity uses to control certain things, and if you're brand new to programming, all of this will go right over your head, but just follow along, do exactly as I do, and we'll get there in the end. So the first position we want to lerp from, well, is just the position that we're at. So we can say GameObject.transform.position. And then where do we want to go? Well, we want to go to a new vector 3. So this is where it gets even extra tricky. So for example, we want our player to be able to, if you watch this this game view here, we want the player to be able to move forward. So, well, we can't actually play because we're getting some errors. But we want to say the player to move in this direction here, right? Well, this is actually backwards. So we want it to move forward. And we want it to be able to move left and right with the controls. But we don't want it to be able to move all the way off the screen, like way off here, because that would not be fun. So we want to actually clamp the position of where it can actually move to. So like say maybe here and maybe here. So it can only move to the different sides of the screen. But we want it to be able to move as far as it wants in this direction. So this one line of code will do all of that for us. So it's a pretty sweet line of code. So we're accessing the transform position equals vector3.lerp, GameObject.transform.position, which is our position now. We want to change that. We want to move from our current position, from our GameObject.transform.position, to a new vector3. We want to clamp that new vector3 with mathf.clamp. And it's asking, well, what do we want to clamp? We want to clamp the GameObject.transform.position.x. So we're accessing the x variable plus move horizontal. So we're now accessing the variable that we declared up here, which is our horizontal axis. Put a comma in, and then we're going to do minus 2.5f. So that's minus 2.5, and because we're using a float, you put the f afterward, comma 2.5. Awesome, so that then clamps our position, and then we want to go past the parentheses and put a comma in, and we want to write GameObject.transform.position.y. Remember where it's asking us for a new vector 3. Oh, and we forgot the f here. And then we want to say GameObject.transform.position.z, close, parentheses, comma, directional speed, which is the variable we declared at the top, times time.delta time. And we want to close those parentheses. So I'm going to zoom out a little bit just so we can see the whole line of code. And it's quite a long line of code. So we're accessing the transformed position. We're creating and we're saying, hey, that the transform position of our player game object equals a new equals vector3.lerp. We're lerping, which is moving smoothly from one position to another. The first position we're moving from is the current position of our player game object. We're moving to a new position, which is a new vector3. The x value on that vector3 is clamped between negative 2.5 and 2.5. Our Y position is just whatever the Y position is. The Z position is just whatever the Z position is. And we're timesing that by directional speed times time.delta time. So the only other thing we need to do is assign our directional speed. So we can go up here and write equals, say, 20. And go back over to Unity. Make sure it updates. Reset. And if we press play, we should be able to move left and right. And I'm just going to right click on the scene view and whip around just so I can see in the direction, see the ball in the direction that we're actually moving. And let's just drag it right back, and let's just get the camera and drag it right back. We can actually bring it up a little bit, and we can actually point it down a little bit. Cool. And if we press play, move left and right, and it stops at a certain position. So if this episode went way over your head, I don't blame you. This is one long line of code, but it's just a really quick and neat line of code. If your project isn't working properly, make sure you copy everything exactly the same. The capitals need to be the same, the points need to be the same, you need to use commas at the right positions, and you need to be using everything here typed exactly the same, and it definitely will work if you've got everything typed exactly how it is here in this script. So that's it for getting the player to move left and right and forward. In the next episode, we'll handle mobile controls.